Hello, I'm Hassan Zock-Obregon.
My name is Paul Frosik.
My name is Ramos.
And this is a presentation on planetary gears. Planetary gears, also known as elliptical gears, consist of at least two gears, one being the sun gear and the other one being the planet. They're held together by a carrier, and the two gears mesh together at the pitch circles. This assembly of the gears is in three stages. You have the input and output shafts. The first gear is attached to the pinion and has a sun gear in line with it. The second stage has a carrier which is mounted to the first, and the whole assembly is held together by a casing. Manufacturing these gears is done in a variety of materials, but the most common being steel. It's also done in many non-ferrous materials such as composites and plastics. Some of the methods used in producing these gears are machining, casting, forging, stamping, plastic injection molding, and powder metallurgy techniques. For the maintenance of these gears, it's good practice to replace washers as well as snap rings and flat washers. It's also good to replace any damaged or worn out gears, and you should try to repair any that have grooves or any marks, and if the teeth are not properly aligned, they should also be lubricated. Due to the large variety of gears that are produced, as well as the many uses that they have, the gears can range in many different values. And I'm going to pass it on to Louis for the next part.
Engineering analysis. This section will cover the numerical analysis of how the planetary gear works. Planetary gears have been utilized since 1700. However, they first started being analyzed in the late 1800s. When we study about planetary gears, we have to assume or we have to remark two constraints. One of them is that all these have to have the same pitch or two spacing in order to ensure that the T will match. The second one is that the number of T's in the ring gear has to be equal to the number of T's in the sun gear plus twice of the numbers of T's on the planet gears. On the picture, you will see a description of a planetary gear where you can see that this is the ring carrier, these are the planets, and this is the sun gear. Before starting to analyze the force acting on planetary gears, it is good to have a relationship in between the gear ratio. If we analyze the number of T's with the velocity that they run, we will get this relationship that we can actually, from there we can actually deduce a formula that we will call train value. That train value will help us to find the relationship between each gear velocity. For the force analysis, each gear in the planetary gear acts as a spur gear. So we can actually use the analysis for the spur gears to analyze the gear, this type of gear train. Assuming that, we can define a torque ratio for standard planetary gear, where the torque of the ring gear will be equal to the torque of the sun gear times the inverse of the train value. Same using for the train carrier. For the stress analysis, we know that most of the planetary gears will fail from gear bending fatigue, ring gear fatigue, and pitting due to contact. If we see the picture, we will see a section of the ring gear where we will analyze to find out the stress due to bending. We will deduce the formula for elongation that we will need to use to apply the Hooke's law, where the elongation will be equal to the distance from the neutral axis, and R will be the ratio of the gear. Knowing this, we can find the bending stress applying Hooke's law, where E will be the Hooke constant. It depends on the material on the material of the gear. That is why it is really important to select the right type of material for the gear that you're trying to manufacture. Since some materials will have different advantage or disadvantage, it is recommended to use this principle that pinions have has to be harder than the gear. When selecting the materials, it is important to think about the strength, the price, the workability, the degree of loading, and the heat treatment of the material. Now, Paul.
So I'm going to talk about the applications of ring gears. The great advantage of planetary gears is that they can provide a large torque ratio in a small amount of space. So that gives them uses in various applications, for example, car transmissions, turbines, clockwork. This is an electric screwdriver. You also see them in 3D printers, either to run the mechanism or to actually be made by the mechanism. So what I really want to go into detail about is the transmission for the Toyota Prius and other hybrid cars, because this is a very good example of an application of a planetary gear system. The Toyota Prius uses 2 electric motors and an internal combustion engine running in concert to drive the vehicle. These motors are hooked up to a planetary gear system. You can see it down there, with one of them hooked up to the sun gear, one of them hooked up to the ring gear, and the internal combustion engine is hooked up to the arm that's hooked up to the planets. And the differential then is attached to the ring gear, and that moves the power to the wheels. Now, the great advantage of this system is that you can vary the power going from the electric motor, and this causes it to act like CVT, that is continuously variable transmission, but without the elliptical gears that often break and cause trouble in other continuously variable transmissions. In addition, the electric motors can start the internal combustion engine, thus eliminating the need for a starter motor. In reverse, the internal combustion motor can also recharge the battery, which then can be used to drive the electric motors. And all this in concert provides excellent fuel efficiency for the vehicle. So what we have here is a demonstration of this system in action. We start out by driving the car only on electric power, and this runs until the car is going at about 40 miles per hour. And then you can see that at this point, the second electric motor doesn't have enough power to keep up. So the internal combustion motor turns on, and then you can see the direction of the sun gear is reversed. And so now we're charging the batteries and we're driving the vehicle on hybrid power. This makes it very efficient. We have some other applications as well for planetary gear systems. We have clockwork mechanisms. This was the original application of planetary gear system. It's also what gives it its name. And it was found a ancient device for measuring the movement of the sun and the moon and the planets in the first example of an analog computer. It's called the Antikythera mechanism, and what we have here is a modern recreation that can fit on your wrist. We also found a patent in the 1960s. This is a mechanical clock that uses planetary gear systems with the correct ratios to drive the minute, hour, and second hands at the correct speeds. So in conclusion, the great benefit of the planetary gears is that you can have the large gear ratio in a small space. You can have planets opposite each other to cancel out any vibration, making for a very smooth operation. There are a couple of disadvantages. We touched on this in the assembly section. It's difficult to assemble and it's difficult to access for maintenance. That said, the large number of applications makes it a very useful mechanism